everyone, I hope you all are doing safe and sound. Welcome to my channel DevOps Tech Stack.
Welcome to the day 5 of the Kubernetes series. So here we are going to understand about the Kubernetes pod, what it is. This is the building block of the entire Kubernetes. This is the smallest object that you can create in your Kubernetes cluster. So today we are going to understand Kubernetes pod in much detail. Okay. So now before we dive into the Kubernetes pod concept, I will assume that you already have a Docker image and you already have a Kubernetes cluster. Kubernetes cluster already we deployed last time using the kind setup. So we have created one Kubernetes cluster where we are going to create the pods. Okay. Now what is the Docker image? Docker image is actually a lightweight, a standalone executable package that includes everything needed to run a piece of software, including the code, the runtime, the system tools, the system libraries, and the settings. Let's say you have created a Python application. So to run that particular application, whatever the binaries, whatever the libraries are being used in your application, everything is packaged into a Docker image. But for now, don't worry about this part. In the later part of the lectures, when we are going to create our own application, that time we will write a Docker file from scratch and then we will build a Docker image out of it. Okay. So for now, what we are going to use, whatever the images which are publicly available onto the Docker Hub, that we are going to use for the few lectures. Later, we are going to create our own and we will push onto the private or public registries. That is a separate one. Okay. Now, what is your Docker image? Let's say you have one chocolate chip cookies. That is your application. That is the end result. Means you have baked one chocolate chip cookies. That is your application. But how that application or how that cookie is baked, that all the recipe is written in the Docker file. Okay. And inside one box, you will package that cookies and that box is called as the Docker image. So you have three concepts. One is the application, the other one is the Docker file, the other one is the Docker image. So in this lecture, we are going to use the Docker image, which is the lightweight standalone executable package that is available on the public Docker Hub registry, and we will just use it to create a pod. That's it. Apart from that, already we have a working Kubernetes cluster using the kind setup. We have already deployed it. So this is the minimum thing you need to have in your system so that we can start with the pod creation. Okay, let's quickly start. What is the pod? So whenever you are going to deploy your application in the Kubernetes cluster, Kubernetes will not deploy it in directly. It will deploy that particular application in form of pod, and inside that pod you will have the container running, and inside that container your application is running. What is Kubernetes? In the Kubernetes cluster you have multiple nodes, right? Last time already we saw that if you run this particular command, kubectl get nodes, you will see that three nodes are available on your Kubernetes cluster. So whenever you are going to deploy your application, the application will be deployed in form of pod into one of the worker nodes. So this is my control plane node where all the system related settings are running. But these are my worker nodes where my application will be running. Okay. Now, so this is my worker node, the big one. Inside that worker node, I have pod deployed, and inside that pod, inside the container, I have my application running. So total three things. The first one is worker node. Inside that worker node, I have one pod deployed, and inside that pod, our container is running, and inside that container, our application is finally running. Okay. So containers are encapsulated into a Kubernetes object called as pod. So this container is basically encapsulated into a Kubernetes object that is called as the pod. Pod is a single instance of application. So if you want to deploy multiple instances of your application, multiple pods will be deployed onto your Kubernetes cluster. So a pod is just a single instance of your application. So if you are deploying one pod, then single instance of your application you are running. If you deploy multiple pods, then multiple instance of your applications will be running into the different pods. Okay. Now, a pod is the smallest object that you can create in the Kubernetes. That I told at the start only, that it is the smallest object which is going to be created in the Kubernetes. Okay. Again, inside one single pod, you can have multiple containers as well, but that is a rare use case. Normally, whenever your application is deployed, it is just having one-to-one mapping. Means inside one pod, one container will be deployed. But there are some cases where you need the helper containers to run the main application. Then in that case, inside a single pod, you will have multiple containers as well. I hope you understand this slide, right? Now, quickly understand, what if I want to scale my applications? I have multiple users accessing my application. I want to scale my application. Okay. So in that case, if you want to scale your application, you need to deploy multiple pod inside your worker nodes. Okay. So this is my single instance of the application, and this is the second instance of my application. If I want to scale my application. Okay. And inside this, my container will be again deployed. And here also the container is deployed. And inside this container, my application is finally running. So if you want to scale your application, in that case, you have to deploy multiple pods onto your worker nodes, right? Again, each pod contains a new instance of your application, right? So everything, whatever is going to be deployed inside the Kubernetes, it is going to be deployed in the form of pod. And inside that pod, you will have your container. And inside the container, your application is finally running. So here also, I just have one worker node. And in that single worker node, I have two pods running. Okay. What if I want to add physical capacity to the cluster, right? So on a single worker node, you are deploying multiple pods, right? And your pods are using the worker node capacity only, right? But in case your worker node is not having that much memory or that much CPU, in that case, you want to run your pods onto the multiple worker nodes. So how that can be done? Again, in that case, if your Kubernetes cluster is already having multiple nodes, so you are going to deploy your pods onto the separate nodes. Okay. How this will be done? So let's say if you are deploying a single instance of your application, that is going to be deployed on the first worker node. And if the second worker node is already available and it is having the minimum CPU and memory, then in that case, the second pod will be deployed onto the second worker nodes. In that way, you are going to add the physical capacity to the cluster as well, and your pods will be running on the multiple worker nodes here. Okay. So further scaling, deploy additional pods onto the new nodes. It adds the physical capacity to your cluster. Now pod can be distributed across multiple nodes. Pods usually have one-to-one relationship with the application container. Means here also one single instance of your application is running. Here also single instance of your application is running. So pod is maintaining a single one-to-one relationship with the application containers. Now, if you want to scale, involves creating new pods, not adding containers to the existing ones. Means inside the same pod, it will not attach multiple containers. Instead, again, it will create a new pod, and inside that, your application will be running. Again, load balancing and service discovery, which we are going to discuss later. That will not be covered now. We will discuss it later. Okay. So you understand now, right? How to scale the applications if you want to deploy multiple instances of your application, how you are going to do it. In that case, the first way is that on a single worker node, you can have multiple pods created. In case of multiple worker nodes, on each worker node, you can deploy your applications, right? Now, what are multi-container pod? Till now what we understood that generally the pod will have a single instance of your application running. But there are some cases where you want to deploy multiple containers in a single pod. That is again a single instance of your application, but your application requires some helper container to process some data. In that case, in a single pod only, you want to deploy multiple containers. So this is the architecture diagram, what I'm going to tell now. This is your worker node. Inside this worker node, you have the pods. Inside the pod, you have multiple containers. One is the app container, that is the main container. The other one is the helper container. Whatever the result you are going to get from the app container, let's say you are going to get some data from this app container, and the helper container wants to process those data. So in that case, in the same pod, you will have multiple containers, right? A single pod can have multiple containers, typically used for helper containers that support the main application. Okay. If they are related and they want to process some data or want to get some data from the app container, in that case, it is going to be helpful use case, right? A helper container processing user data or uploaded files. Helper container lifecycle tied to the application container, right? If your application container dies, then automatically your helper container will not exist and it will automatically be died. So they both are related to each other. Now, how they are going to communicate? They can communicate directly through the local host. They will share the same network, they will share the same storage space, everything will be common. You don't need to worry about that part because they both are deployed into a single pod, right? So now let's say what was the complexity which we were facing when we are using the Docker. In the Docker also everything was deployed directly onto the container, right? There was no concept of pod and these things. So what was the complexity that Kubernetes came into picture? I will just explain with the diagram first. Let's say you have one Python application running. And this Python application also uses one helper container. So you have one helper container and then you have Python application also running inside a container. But if you want this Python app container to use this particular helper container, then you have to maintain this mapping manually. But what I told in case of pod, they are sharing the common space, they are sharing this common network. You don't have to maintain this mapping. They are related to each other. Okay. Once if it dies, then automatically your helper container also dies. But in case of Docker container, what happened? You have to maintain this mapping. You have to maintain that they are deployed in the same network. You have to maintain that they are sharing the same storage space. You have to do it manually. If you have just for testing one or two containers, then it is fine. But what if you have thousands of containers running? How you are going to maintain this mapping? Very difficult, right? But in case of pod, everything is deployed in the same pod structure, right? You have both the helper container and the main container deployed into a single pod. You are not maintaining any mapping. So this is something what Kubernetes is solving the complexity what we are facing in the Docker concept, right? Obviously, how we deployed the applications using the Docker, we just had the command docker run and then the whatever the container name you are going to provide, then you have to provide the image and everything. It will deploy the application in the form of container using the docker run command, right? If you are running the docker run multiple times, then multiple docker containers using the Python image, it is going to deploy and all the applications are running inside the docker, right? So now if your architecture some changes are there and a new helper container is added, let's say here, right, there's some helper container got added. So in that case, helper container maintain a one-to-one relationship with our application container, need to communicate the application container directly and access data from those containers. Now, this mapping you have to maintain, you have to establish the network connectivity, you have to create a shareable volume that can be shared among the containers. Okay, so once the complexity increases, then Docker is of no use. It will be very complex and you can't use it. So the concept of the pod came into picture and this resolved that particular issue. Kubernetes automates the complexities. It defines the container within the pod, and the containers in the pod share the same storage network space and the life cycle, everything, right? So you understood what concept or what issues you were facing in Docker, and that got resolved within the Kubernetes, right? Now, now, the very first thing is how you are going to deploy the pod onto your Kubernetes. I hope till now you understood what is pod, okay, and what are multi-containers pod, and what a problem is it resolved, what we were facing in the Docker. So all those things you understood. Let's now understand about the pod, how you are going to deploy it. Even if your application is going to require a single container, everything in the Kubernetes will be deployed inside a pod. So that if later any architectural changes are there or your project requirement changes, your complexity increases, everything you can maintain. You don't have to face that much complexity. Okay. Multi-container pods are a rare use case that we are going to see later also. Okay. Now, how to deploy a pod using a single imperative command. So for that, you have the command kubectl run. Again, just like Docker run, you have to run the kubectl run command. After that, you have the pod name. What is my pod name? My Nginx is the pod name. After that, you have the hyphen hyphen, and then you have to provide the image name. What is my image name? Image name is Nginx. So this particular image, from where it will download. So it will download from the Docker Hub public repository. Once you run this particular command, your pod will be deployed. But from where this image is coming or from where this image is getting downloaded. So it is being downloaded by default from the Docker Hub public repository. I will show you the Docker Hub public repository. Docker Hub public repository. Okay. And if you search over here with the name Nginx, you will get that particular Docker image. And if you are not mentioning any tag, the latest tag will be pulled. So this particular Nginx image will be downloaded onto your Kubernetes cluster inside the worker node, and then it will deploy this particular Nginx image inside a pod, inside a container, right? The same thing what I explained in the diagram as well. So from the Docker Hub public repository, you have Nginx image already stored. So Kubernetes will pull that particular image from the Docker Hub by default. So let's quickly run this particular command. I have my Kubernetes cluster. So what I'm going to do, kubectl run, then give the pod name, and then what is the image name what you are going to give? Hyphen hyphen image, hyphen hyphen image, and then Nginx. Okay. And your pod is created, right? So if you now run the command kubectl get pods, you will see that this particular pod is being created and it is in the container creating state. So this workflow and everything I have already explained in my previous lectures. You can go through it, how this particular flow works so that you can understand it in much detail. So now if you run the kubectl describe pod and then the pod name my nginx, you will see what all events are going to happen. The very first thing is that this particular pod is scheduled on some particular node. So what it is scheduled onto the node find worker. Okay. After that, it will pull the image nginx from the Docker Hub. Then it already successfully pulled your image, and then this image is ran inside the container called as the my nginx. Okay. So this is the flow how you are going to create a pod using a single command. That's it, right? What is my command? Kubectl run, then the pod name. After that, with the hyphen hyphen image, the image key, you have to provide the nginx Docker image name, right? This is the workflow. Now, kubectl run is a quick way to deploy a container in the Kubernetes. It automatically creates a pod that we already saw. It then deploys the specified container inside that particular pod. Think of a pod as a wrapper around your container. Means your container is encapsulated inside the pod. And with the hyphen hyphen image parameter, you specify the Docker image to use. Right? So this you understood, like using the imperative command, how you are going to create a pod using a simple one-line command, right? You already understood. But this is not the proper way. You have to maintain your YAML file inside the GitHub. So in that case, you have to create the proper YAML file for all these things, right? So how you are going to do it? This I already explained that using the kubectl get pods command, you will see what all pods exist in your Kubernetes cluster. This namespace thing I will explain you later. Okay. Now you can understand what is the pod status. Currently, it is in the running state, means the container is running successfully. Otherwise, if it is the image is downloaded, then in that case, it will be in the state container creating. Now, if there are some error or it is in the pending state, some nodes are not available, in that case, it will be have the pending or error state. But currently, your Nginx web server is not accessible from outside the Kubernetes cluster. So that those things, service and everything, I will show you later in the later lectures. But for now, I'm just showing you how you are going to deploy the pod. Okay. Now, how to create a pod YAML? The syntax is very simple. Whenever you are going to create a pod, you will have four top level fields. The first is the API version, the second is the kind, the third is the metadata, the fourth is the spec. Fine. These four are the mandatory field that you have to write in every YAML file related to all the Kubernetes components, right? The very first thing is the API version. So this is the version of the Kubernetes API, which is going to create the object. For each of the Kubernetes components, like if you're going to create a pod or deployment or replica set or stateful set or service, for everything you have some different kind of API version. So this version actually helps the to create that particular type of object. Then in the next kind is the main where you are going to specify what kind of object you are going to create, right? So I am going to create a pod. The third is the metadata. What is metadata? It is actually the data about your Kubernetes object. Here you can maintain all the labels or all the tags related to your applications, right? So about the data you can mention inside this particular metadata section. Metadata is again in the form of dictionary data type. What is dictionary data type? In dictionary data type, you maintain a key value pair. Okay. So what is that? The inside the metadata, the very first thing what I have mentioned that the name. What is the name of my pod? So my pod name is my web pod. Let's say. Okay. The next is the labels. I will explain you why labels are very important. So inside the metadata, you can check the Kubernetes documentation also that what fields are allowed. So you will see name and labels are allowed fields inside the metadata section, and this is in the form of the dictionary. Again, inside the labels, you have multiple key value. So here you can specify any labels based on your application. Like if your application is front end type, then you can specify type as front end. If it's a database, you can mention the type as the database or backend, anything you can specify under the label section. But inside the metadata, you have to specify name labels, whatever is officially allowed that you can mention over here. Now, what is the next is? The next is the spec section. In the spec section, you are going to specify all the details about the image through which your container is going to be created. Again, in the inside the spec, you have the mandatory field called as the containers. Containers is kind of type of list, right? Because you can have multi container also inside a single pod. So its type is list. So the very first uh, container what I'm going to deploy inside the my web pod is the Nginx container. So inside this, again, you have to provide the name of the container. The name is the first list in this particular container item is the name is the Nginx container. It is going to use the image Nginx again, what we already saw, right? So this is a simple YAML file with all the details, which is going to help you to create a pod, right? Again, you can go through this particular all the descriptions, whatever I have mentioned over here, but I have overall explained what it is going to create. But this label section, I will explain you again. See here what I have mentioned. Okay. Say, for example, there are 100 of pods running a front-end application and 100 of pods running a back-end application or a database. It will be difficult for you to group these pods once they are deployed, right? So based on this labels value, only you can group this particular pods. So that's why your labels are very important. Once you create service also, then you will see that you will mention their labels that which all pods that particular service will maintain or will track. So these things will use the label only. So that I'm going to explain later when I'm going to show you the real use case of labels. But for now, you can understand that this labels is very important, which helps you to identify your pods. Now, once your YAML file is created, how you are going to create it? Using the command kubectl create, and with the hyphen f, you have to mention the YAML file name, pod.yaml, whatever is there. Okay. So let's try to create it. First, kubectl get pods. You will see your pod. Okay. Now, if you want to delete this particular pod, kubectl delete pod, and then the pod name. Pod name is my nginx. Okay. This is done, right? Your pod will be deleted. If you run this particular command again, you will see you don't have any pods. Now I want to create via YAML file, by a declarative way. Go to insert mode. The very first is API version. What is my API version? API version is V1. The next one is kind. What is the kind? I want to create a pod. What is the next section? Next is metadata. Here I'm going to create name. Name is my first pod. Okay. The next is the labels. Inside the labels, you can have, sorry, okay, multiple key value, right? So let's say I am giving type. Type is test. Let's say, okay. The next is spec. Again, you are seeing, right, how I am maintaining the spacing. So under the metadata, you have to maintain some space, and that space can be anything. You don't need to be proper, but the name and labels should be on the same line because it is sharing the same top level metadata. So it need to be in the same level. Again, if I am writing a spec over here, it need to be on the same page. These lines will be same, all the top level field, right? API version, kind, metadata, spec, everything will be on the same line, right? And if you're writing something inside this, then it need to be slightly on the right side. So again, inside the spec, I have the containers, and the container type is list, right? Sorry, I'm using a Japanese keyboard. Okay. The first item in the list is, let's say, the name of the container is my container. Okay. Might be something might go wrong also. So we will see later. The images. Sorry, here again. My first container. Okay. The next is image, right? What is the image? The image is again Nginx. You can use something else also that we are going to see later. That's it, right? You are going to save this particular file, and then you can run the command kubectl create -f and then pod.yaml. Okay. The pod is created. Now run the command kubectl get pods. And your pod is running. Why it was very quick? It was very quick because your image is already downloaded onto your worker node. And so it didn't download it again because we are using the same latest stack. So it didn't download it again and it was very quick. And if you run the command kubectl get pods -o white, it will show you that on which particular worker node this particular pod is deployed. Again, it is on the same node, kind worker. And on this node, your Nginx image was already available. So it didn't download it again, right? And if you want to get into detail of this particular command, again, you can run the command kubectl describe pod and then the pod name. You will see everything here. What are the events? What happened when you are deploying the pod? What will happen? Apart from that, on which namespace it is deployed, these things you will not understand for now. On which particular node it is deployed, you are seeing that on the kind worker node it was deployed. What is the IP of your pod? What is the status of your pod? What are containers inside this particular pod? So you have a single container, what we created, what image this container is using. So it is using the Nginx image. Everything you can see over here. Okay, okay. These things you can try on your own, but if there is some doubt, then you can let me know in the comment section. Okay. Inside your Kubernetes cluster, you can check how many number of pods are there inside your Kubernetes cluster, right? How you are going to deploy a Nginx image. So that I already explained. You can do it from your side as well. Again, I already showed you that using the kubectl describe command, you can check which image is being used by the pod. Okay. Now, how to check the pod is running on which particular node? -o white I already showed, but you just try on your site. Okay. How to delete the pod? How you are going to deploy a Redis pod? So you can use YAML to do that. So in place of Nginx image, you are going to use a Redis image and you are going to deploy a Redis pod. Okay. But in case you don't want to write your YAML file from scratch, there is a single command also using the dry run client option, you can store its output inside a YAML file, and then in that case you can then apply this particular redis.yaml file. So dry run client will not basically create your pod. It will just give you a simple YAML file, and that YAML file you can use to deploy or create your pod. This you can try. Otherwise, in my next lecture, I will try to do like this only instead of writing it from the scratch. It will take some time. So we will do it like this using the imperative command, and with the run client option, I will store its output in the YAML file, and this YAML I will apply to my Kubernetes cluster. I hope the concept of pod is now clear to you, but slowly everything is deployed. At the end, everything is deployed in form of pod. So this we are going to use it extensively always in the entire lectures. So let me know in the comment section if you like this particular lecture. Thank you again for watching our videos. I hope you are liking it. Thank you.